Welcome to Chapter 9. Our last chapter we talked about was Chapter 6. That was chemical equations and stoichiometry percent yield. And you might think, well, why not 7, then 8, then 9? Well, it turns out it makes more sense if we do 9, which is solutions. And then we can do 8, which is gases. And then we're going to do 7, which is the rates of reactions and things like heat of reaction as well. So it just plays better because solutions help us when we get to gases, but particularly help us when we get to Chapter 7. So our textbook, I've told them before, I really think Chapter 9 should go before Chapter 7 and 8, but they don't listen to me. So here we go. So what do we mean by a solution? So a solution is something that I'm going to abbreviate to SOLN and is made up of two parts. It is made up of a part that we call the solute, and it is made of a part that we call the solvent. And our definition of solute versus solvent is the solvent is what we've got the most of. So if we've got 3 or 4 or 5 things mixed together, whichever we've got the most of is called the solvent, and then the solute is what we've got the least of. And there may be more than one component here in the solute, but there's only ever one solvent. So some examples of solutions are things like seawater. And so seawater is a solution, and the thing we've got the most of is water. I guess that's why we call it seawater. So water is the solvent. And what else is dissolved in there? Well, we've got things like salt. And there's lots of different types of ionic compounds here that we all call salt. But salt would be the solute. We can have other solutions as well. So an example of another solution might be something like vodka. And vodka is a solution that, again, primarily consists of water, about 60%, and the rest of it is alcohol, and the alcohol is about 40%. In fact, Dmitry Mendeleev, the guy who discovered the periodic table, was commissioned by the Russian government to figure the best ratio of alcohol to water. And here's a very nice picture of Mendeleev right here with his periodic table. And it looks a little weird to our eyes, but Mendeleev was the guy who figured out that optimal vodka-water-alcohol ratio. And here's 3 more solutions that are sort of surprising. Air is actually a solution. And if we ask ourselves what is the solvent in each of these, that is the thing that we've got the most of. And so in air, it turns out that nitrogen. So nitrogen is N2, that's the gas, that is the solvent. And the solute is what we've got a smaller component of. And so in nitrogen, in air, that's about 78%. We've got oxygen, which is about 21%. So this would be a solute. And surprisingly enough, about 1% of the air is actually argon, that noble inert gas. So right now we are breathing in, for every 1 liter we breathe in, we're breathing in 10 milliliters of this argon, this noble gas. Wow, that's really cool. If we look at club soda, so if you're not sure what club soda is, here's a pic. Club soda is also a solution, and water is the solvent, and the solute here is actually carbon dioxide. So that's what gives it that tasty fizz that you can mix your, whatever you prefer to mix with it is, I suppose. And our last example of a solution is something like brass, which is about 2/3 copper, 1/3 zinc. So that means that copper is in the largest component, so that's the solvent, and the solute would be the smaller component, that is zinc. And there may be a few other elements in there too, like lead and tin and iron, let's say. So those could be other components right there. So there's some lead, and there's some tin, and there's some iron. So we've got 4 different solutes there, but 1 solvent. So brass is very shiny, right? It looks very similar to gold, but it's definitely not gold. So when most of us think of solutions, right, we think of maybe a solid sprinkled in some liquid, like sugar in water or salt in water, but it doesn't always have to be that case. So this is an example of air, which is a gas, a gas dissolved in a gas. And club soda is an example of a gas dissolved in a liquid. And brass is an example of a whole bunch of solids dissolved in a solid. Sometimes we call this one an alloy, by the way. So these are all solutions. They're homogeneous mixtures. So there's multiple components, but they're all dissolved neatly so that when you look at it, there's not like a lumpy place where there's a little more zinc or a little more lead. They're perfectly distributed throughout the entire solution. So when we're working with solutions, there are 4 or 5 terms that are convenient to know. So dilute, I think most people are familiar with, but the technical, definition is that it's got a low ratio of solute to solvent, or multiple solutes to solvent. So there's just not a lot of solute, a lot of solvent. Concentrated means the exact opposite, if you like. It's got a high ratio of solute to solvent. There's also 3 other terms: saturated, unsaturated, and supersaturated. And saturated means that there is the maximum amount of solute that can dissolve. So max amount of solute. I didn't win any awards for handwriting, I'm afraid. That can dissolve in a given amount of solvent. So given amount of solvent. And unsaturated just means that there is basically less than the maximum amount. So you could dissolve more if you like. And supersaturated seems like it shouldn't exist. Supersaturated means there's actually more than the maximum amount that can dissolve. So how is it possible to have more that can possibly dissolve? Well, it's actually unstable. So it turns out that you can trick it and you can get it to dissolve for, seconds or minutes or hours, but you're never going to be able to keep it in solution permanently. So think of something like honey. So honey is sort of sugar and bee spit. And if you leave your honey kind of sit around for a while, you notice that it gets crystalline, it gets really hard, and that's because all that extra sugar that shouldn't dissolve is actually crashed out of solution because that solution was supersaturated. Here's an example not of honey, but of some sodium acetate. And so this sodium acetate was dissolved in hot water. And as it cooled down, all that sodium acetate stayed in the hot water. And when it cooled down, the water became nice and cool. And then eventually something hit the surface, probably right here. And it triggered this reaction where all that extra sodium acetate crashed out of solution. And this would grow and fill up the whole beaker over time. One more piece of terminology is an aqueous solution, and so an aqueous solution is one we've used in the lab a lot. And what does aqueous mean? It means that water is the solvent, and these are the most common solutions we use in the introductory lab. And of course, as a person, we are mainly water, and so all our solutions in our body are hopefully aqueous.